When I talk about construction in schools of architecture, when we talk about vernacular construction and historic building and building without architects, I'm usually told that the material choice for construction is down to the materials that are available in a locality. When you look at the use of materials, you find the use of local indigenous materials. So if you go to South America, if you go to the Amazon, you find the use of timbers and bamboos and leaves. If you go out into the plains of Turkey, you find the use of the local indigenous material mud to make buildings. But timber exists in Turkey and is widely used in construction, just not permanently. Mud is widely available along the banks of the Amazon, but they don't use it for building their houses. So we have to ask why. We have to observe and we have to question. Evidently, the Amazon, Ecuador, is in the tropical belt. Turkey is in the arid belt. That fundamentally changes the climate. The moisture in the air in the tropical belt gives it loads of thermal mass. It doesn't get cold at night. If it doesn't get cold at night, you don't have a means for using thermal mass to cool buildings, so there's no point in having it. You want lightweight, open buildings which are going to transmit the breezes. In the arid climates, there's no moisture in the atmosphere. The temperature swings widely between day and night. You want loads of thermal mass in your buildings to capture heat from the sun during the day and keep it there at night. Dwellings have evolved as a product of the need to produce a safe and homely environment in exactly the same way as it has happened for birds. We can look at birds' nests as an example all over the world, and we can identify the differences in construction between cold climates where it's necessary to keep the eggs warm so they don't freeze, and hot climates where it's necessary to keep the eggs cool so they don't boil. We ought to consider that historic construction built to enable people to survive and to reproduce successfully is an extended phenotype, and therefore we can learn from examination the wisdom of evolved knowledge, fitness for purpose, if you like, that embodied in old buildings there's a lot of wisdom that we ought to be trying to uncover. Ways of dealing with light, ways of dealing with breeze and thermal mass and cooling, and ways of avoiding glare, getting just about enough light. Now, I think I can demonstrate this sort of evolution with a quick thought experiment. If we were to examine how much light do you actually need to live in your living room? When we look at cold climate buildings, we find they've generally got small windows. Why have they got small windows? It's obvious. Heat escapes through the windows, so it's quite important to make those windows as small as possible, but not so small that you can't do domestic chores. You've got to optimise between heat escape and light coming in. And if you take one of these traditional buildings, a traditional room, about 12 square metres, normal kind of surface reflectance and a typical window size for a cottage, you find that you calculate it out, on a dull day, you get an internal light level of about 65 lux average across that room. Then consider that until they were recently banned, the most popular selling light bulb in Europe and North America was the 100-watt light bulb. And if you put a 100-watt light bulb in that room, it gives you about 65 lux. So there, through two completely different processes of choice, the choice of having more light and being colder, and the choice of having more light and paying more money to Tesco's, we have made two choices which have both converged on about 65 lux. 65, 70, it's give or take, being about the right level of light for a living room. And I can demonstrate this in another way. This is a very high status dwelling, trust me. This is not a cottage. This is back in Rajasthan, it's in India, where on a day like this, outside, it's 150,000 lux on the ground. And in order to control that level of light and to control the glare, the response is to build these very, very deep veranda in order to control the light that penetrates the space and control the heat. This is sitting in somebody's living room, discussing some architectural drawings in the light level that has evolved in these high status dwellings for living. And I was just curious, so I stuck my light meter on the table And there it is. It says 72.7 lux. So even in these high status dwellings where light is not being bought at a premium, the balance between availability of light and overheating has tended towards around about 70 lux. If we look at the light that you need for working now, in a lot of the world, industry still takes place under the open sky. That's great, loads of daylight available, no need to worry about it. When you come indoors, things get more difficult. You need a lot of light to be able to make textiles. You need to be able to see threads that have missed. In parts of India, you find electric lights hung from strategic points all over the looms to give you the working level. But if we look back to the history of UK industry, we didn't have electric light. You had to put bigger windows into your houses to accommodate the early looms. And this led to a completely new departure in the design of dwellings to accommodate looms in our northern cities. Now here's a curiosity. These windows here are obviously much bigger and they're a different proportion, they're a different character to the dwelling windows. They're there to accommodate the loom lofts. But why on earth would you put a loom loft on the top of your house when it means you've got to carry the loom upstairs, you've got to carry all the raw material upstairs, you've got to carry all the finished cloth back downstairs again? It's an awful effort. Why would you do that? Well, you do that because actually putting the loom in the loft gives you exposure to much better daylight because you're looking over the roofs of the surrounding buildings, not directly into their walls. And when we do the calculations on a loom loft, we come up with a number of about 500 lux. And it's not a coincidence at all that 500 lux is the design recommendation for office workspace lighting. So again, two completely different paths have converged on the same number as a result of a need. And by understanding these evolutionary processes that lead us to these convergences, maybe we can start to unearth some real intelligence. And again, here's a worked example. This is somebody's office. This is actually a farm office on a farm in India. The farmer Baburam is not actually in this photograph. This is us standing around with the architects and other engineers discussing a project that we want to develop on this farm. But you can see this office is quite big. There's plenty of space where Baburam could put his table. He could put it here at the light edge of the veranda, or he could put it there at the dark edge of the veranda. This is the table where he sorts his seeds. So he's got to be able to spot a seed which is dead or decaying or shriveled from all the good seeds. It's also where he does his accounts. So he's writing with pencil on paper and things like that. And just out of, he could choose to put his table anywhere in this range from light to dark. But he put it where he did. And I was just curious, so I put my light meter on the table again and measured 519 lux. So there he has free choice. Darker, lighter, he's chosen just right.